Hi guys, this is the walkthrough for using ezExperimenter. I will define the environment of the app and how you should prepare your data to run your experiments and what else. Then I will show you what is the structure of the code for those of you who have more coding skills and want to modify the code for your own use cases. But it really works for many occasions as far as your model supports the use case that you want to use. Another thing is that it can support OpenAI as well as Firework, which is an open source platform for using, and it is safe. It is a safe open platform to play with LLMs. You can use serverless models. Also, you can fine tune these things, these LLMs and VLMs. You can use Runpod to create your own server and send your requests to your cloud. You can also use HuggingFace inference or Ollama, which is a local application, which is an application to run local LLMs, or you can also use any other services as far as they mention that they are OpenAI compatible, which means that they support the way that you send requests to OpenAI and receive the output. So before going to these sections, first I want to show you how you should prepare your Excel file. The code will read your Excel, and each request should be placed inside one. So this is the example. You should put all of your prompts inside one column, and inside another column you can define the path to your image separated by comma. So this is one when you want to provide one image, and this is the example when you want to provide two images. This is like comma separated. My font is like too small. I don't know if you can see that or not. So from that point on, you can read that Excel to create one or two or as many as you want experiments. This is supported by asynchronous calling, which will increase the speed significantly, and you will define the temperature, the name of the model, the batch size. This batch size means that you will send 30 requests and receive them at once. So it is like roughly 30x times faster than just like sending the requests one by one. This is the max token. This is the system prompt. This is the row when you want to start the experiment, and this is the end row. If you feel this empty, it will go with all of the rows that you have. So this is the Pydantic object, so you can get a structure outputs. And what else? I will show you one example where I define the structure output and receive the output in a JSON format. And if you want to use the image column, you should also check this box. You can also, like some of models also support both JSON and image ingestion, but you should check their model card or description, whatever model that you want to use. And from the left sidebar, you can define any platform that you want to use, and any of these platforms should have the base URL. And you should also save your API key inside .env file and provide the key to your API here. And this is basically where you will save your output. So yeah, that's it. What else? So at the end, you will press provide the code, and you can just get the code and run it in your Jupyter notebook. you should you can run these experiments here, but there was two concerns that I made this unavailable. The first one is that if you use this on using like any online platform, there is a chance that you will leak your API, which will cost you. And the second one is that handling the asynchronous calling inside a Streamlit, this is like a Streamlit based application, is a bit tricky. So no running for now, just get the code and run it in your notebook. So I will start with the example first for those of you who are not interested in seeing the structure of the codes and functions. And at the end, I will walk through the code also. So let me start by one real world example. So I will, from this point on, I will show you all of the steps that I'm doing for any, like for a real world use case. So we previously collected about 200,000 articles, title and abstracts from PubMed. So we wanted to use LLMs to extract some of the information about the disease, about the target population, about number of like training set size, number of events, cohort definition, data type, and all of these other things. So the first thing that I should do is to create a column for my prompts, for my input data. So this is called, let's call it prompt. So for prompt, I want to have the value of this. I want to have it like this. First, this is the title, and then the title, and I don't know if it's gonna work or not. And then I want to mention that I have the abstract, which is inside this column. Yeah. So let me see that. So, oh, sorry. Yeah, it's better now. So let me see one of these things, values only. So it's title and then abstract. So I don't know how to go to the next line using the formula. Let me check that out. I should put character 10. So it would represent the one new line. So let me just quickly check the output. So this is my output. These are my prompts. So this is title, then abstract, and all of these abstract of this article. So this is ready to be used. So let me just download the Excel file. So it's done. From this point on, I just want to use these Excel files. So let's start using the app from the really basics. The first thing you should do is to download Python. For the reference, I am using Windows, and the code will be it will work on Windows, I guess. So download Python, then download VS Code for any device that you have, and that's it. So you have the Python and VS Code. So the next thing to do is to go to the Not Carney lab. LLM is all you need, and then you will need the files inside these ezExperimenter point one. So you should download all of these files, which contains the code for running your Streamlit application, as well as the code for running your LLM and VLM. You can go to this download directory.github.io to download this folder. It is easier to do it. So when you are inside this folder, you just need to copy this URL, put it here, and press enter. So it will download it for you. And then you should unzip this file at some place that you run. So I will have it inside my desktop, and where's the folder of it? So experiment test. So I extracted all of the files here inside a desired folder called ezExperimenter.test. And from this point, you should right click on this folder and open it with VS Code. In Windows, it is easy to do this. So you just need to right click and press open with code. So now I have access to all of these files. The generation contains the code for generating the output using asynchronous or synchronous functions. The handlers are for handling Excel and JSON files and asynchronous experiment handler. And this is my test when I want to start playing with anything. First, I will test it out. But there is nothing, there is no need for you to know these things. The only thing that you should do is to go from this top bar, open the terminal, and write down Python -m venv, and then you should create a virtual environment. This means that you will create a virtual environment isolated from your base Python engine. You can just leave it as venv. So this is the name. You can name it anything that you want. So Python -m and then venv and then the name you want to have. So as you can see, it added a folder which is venv, and inside this script I have my Pythons here. So when you want to, so now we want to activate this engine to install the libraries. For this, you just need to write down venv, the name of the virtual environment you created, and these backslash, I guess, and then a script, and then activate. So venv backslash scripts backslash activate, and if you press shift, it will it is autocomplete. It will trigger autocomplete. So now you can see that I have venv here, which means that my virtual environment is activated, and anything that I type it will be anything that I type here, it will be ran through my engine called venv. And now I want to download all of these libraries with their versions. There is no need for you to go over these things. Basically, we are using Pandas and OpenPixel for playing with data frames and Excel files. This is the library to print out progress bars, some mathematics. These are for asynchronous calls. This is for Pydantic objects, which will be used to define a structured output for the OpenAI compatible requests. And this is the Streamlit. This is the library for our application. So the only thing that you should run is here. I never this is pip install r, and then use the requirement.txt to install all of these things. So this is the app file. The Streamlit application is here. The use is the notebook that we can use for running these things. I put my own notebook for you guys. This is my unit test for my own use cases. Please update. So for any test function that I have these things here. This is the URL of the service I want to test. This is the API, and this is the path to the test image, which is here. This is the doc test. You should update this one. Also, you should update the model name for the LLM test and VLM test. And then you have the test for handlers, test for run multi-pair experiment, and this is the code for experimenting. This is real world code for my own use cases. This is for using Firework service and so on. Yeah, I was talking about these experiments, these codes for experimenting. So this is for Firework, HuggingFace, Ollama, Runpod, and Quen. Like this is using Runpod, running Quen on Runpod, and that's it. There's no need for you to go through all of these things. These are like just for those of you who want to do the coding for themselves without using the app. So as you can see, all of these libraries are downloaded and there is no error. If you saw any error with the P version, this is not important. But if you want to resolve it, you should run this command, which is not needed at all. So it's done. The next thing that we want, but if you close your terminal by any chance, you should activate your virtual environment again. So you should go with venv, again script, and then activate. So now you should run the Streamlit app, and for doing this you just need to enter Streamlit run app.py, and when you enter this you should see a browser window pop up in your system probably. So this is the application environment as you saw previously. So let's start with a real world example. So we already created the Excel file. Now we want to use LLMs. So when we want to use LLMs, we either want to get OpenAI, we want to use OpenAI. We can also use HuggingFace, Firework, or anything else. For this instance, I will just show you each one and how you should set up get your API and use them. So for OpenAI API, you just need to get OpenAI platform, and then you should log into your system. Or sign up for an account and then log in. After you logged in, you should where's the API reference? Where's the API? Let me check. So it should be on my profile. Yeah, this is on my profile. So you should go to your profile here, and then you should go to the API key and then create one API key, and basically can name it anything, and you can define any project that you have to account for your costs and keep them, like track them. And you can create this API and this secret key, and then you should copy this and put it inside the .n file. I assume that I already created, no, you don't have any .n file. So you should create a new file named .env, and you should define your API here. Let me come. So it's like OpenAI. You can name it anything that you want, but this is the standard for OpenAI. So this is your API key right now. I hope that I can remember to delete this one. So after our video, hopefully. So this is our API key. Now we should save this .m file and then go to, so it's done. We can now use any OpenAI, and you should provide the name that you define for your API here. This is the base URL for OpenAI. There is no need to change it. And this is the path to save your outputs. Let me define it like this, my outputs, and this is the path. So this is the path to the desired folder for get the output. So for this experiment, I want to have, for example, 2 experiments. The experiment name, the first experiment is GPT-4 with temperature of 1 and what else? And the simple prompt. This is just the name that you can define for your experiments. So this is the you should define the Excel path. So this is our Excel file. I previously showed you, but to be sure that you are aware. So this is the column that we want to use, name prompt. So yeah, I get the path to this file. Sorry. Yeah. Show more option, copy as path. So this is the path, and you should define it like this, and then you should press read columns, and when you press this you can get the list of your column names. So my prompt column name is prompt, and the temperature is 1. The model name, for model names you can go here, I put the link here. You can define, you can use any model that you want. I want to have this one. This one, yeah. So I don't have any image column, but I want to create a Pydantic for my experiment. So you can do all of these things for experiment 2. So let's just have it as one experiment. No, let's have it as 2. So this batch size refers to like number of requests that you can send at once. For this, you should check your tier, OpenAI tier limits. It's on here. No, limits, is that it? Yeah. So currently I'm at I don't know, you can see these limits for me here. I'm on tier 3, which means that when I use GPT-4o, I can send 5,000 requests per minute, which is a lot because I put a lot of money into this account. So and this is number of tokens per minute, which means that like tokens are something like word, like you can double the word to estimate tokens. For example, if you have, let me show you one example. This video would be a long one. So if I want to know the number of tokens to just give it an estimate, I can go with like either word counter, or I can go with like token counter. And I can just copy and paste some of these inputs to know the number of tokens. So it's like about 300 words, 270 words. If you double this, you can estimate for the tokens. So we should have like 500 tokens, I assume. Yeah, it was a good guess. So this is number of tokens, and assuming that each input is 485, and the output should be like 100 words, which is like 200 tokens. So we should have this like about like 1,000 at utmost. The maximum of each request is 1,000 tokens. So you can calculate this and get your correct number of batch size. But I can go with even like 1,000. But let me complete the example. So for each request, I can send, sorry, it's midnight and my mind is not working that well. So yeah, so I can send 800,000 tokens per minute. So it's like I can send 800 requests, and also these 800 requests is lower than the number of requests I can send. So I can easily go with 800 requests per like minute, and if I can get the time of each inference, then I can calculate the number that I can use for batch size. For example, if one request gets 10 seconds to be completed, I should do like 8 times, like I should divide it by number of like total inference in 1 minute. So I can send 132 requests for each batch. Yeah, so this is the batch size, and one example that you can define the correct batch size. So this is the max token for generating the output. This is the system prompt, and this is the starting row and the end row. If you just want to get the output for some number of rows. Yeah, so as I said, I want to extract things from this text, so I want to have Pydantic objects, and I will wait here to drink something and then continue. So what is Pydantic? Pydantic is a way to define your desired structured output for the LLM. And for this case, I want to extract some information from scientific articles, from the abstract of scientific articles. So I would name it as information extractor. If you put spaces, it will handle it, but you should avoid putting a space for any object name. But if you put any space, the code would resolve that. Information extractor, abstract info extractor. So this is the main Pydantic object that I want to use, and I should set the root to this desired Pydantic object. Then I should add fields to this Pydantic object. So let me check what I had inside my article. So I had the target population, the disease, and control. So let's go with the disease. So I want to have a field called disease, and for the type of this object is a string, and I don't want a list. I just want to have one object for the name of the disease, or I can have a list. Let's see. Let's have a list, because we can have like multiple diseases for each abstract. So yeah, and the description is the main disease that this article aimed to develop machine learning So yeah, there is no, we don't want to limit the output to anything. So that's it. So we have the disease now. Let's go with the next one. Training set size. Training sample size. mention the, so what I will do for my own projects is that first use one LLM to extract information without any forcing on options, and then I would use a second run to clean them using LLM. So here I don't want to like put pressure on sample size, so I would go with a string. But the correct way of doing this is like integer. Let's do it as like having it as integer. So mention the number of patients sample size, like patient sample size. Mention the number of patients included in this study for developing the model. And this is not a list for sure, and it is integer. Yeah, so this is the patient sample size. Let's go with some other things. Cohort definition, number of events. Yeah, number of events. The number of events, for example, the number of events in the sample size. For example, number of cancer incidents if the project is aimed for cancer diagnosis. Or number of deaths if the project is aimed for cancer survival, for example. So this is integer, yes. And you can go with doing this to complete all of these things. But here I want to do a cool thing, which is defining one Pydantic object as the feature of another Pydantic object. This will enable you to get many cool structure outputs. So I want to get the list of related specialties with the degree of relevance. For example, if it is on pancreatic cancer, it is highly related to gastroenterologists, surgeons, what else? It can also be related to radiologists or pathologists, depending on the title. So also there's a degree of relevance, which means that, for example, hematologists also can be included inside this list. So I really want to have one new object named specialty relevance. So when you create it, you should change it here. So let me remove these things. So for specialty relevance, I want to have the name of the specialty and the degree of relevance. And if I have a list of these objects, I would get a cool output for this thing. So the specialty relevance, for specialty relevance, which is a Pydantic object, I want to have name of the specialty name, which is a string. The name of the specialty should adhere to the standard specialty and subspecialties. Specialty to the standard specialty and subspecialty categories in medicine. And This is also something that is not official. So this is it. So a specialty name is a string, and then we want to have degree of relevance, which is a string. The degree of relevance considering the manuscript, the abstract, the relevance of abstract with the specialty, considering the abstract topic and aim, for example. So for this one, I want to have low, moderate, and high. You should separate them by comma. So it's done. So allowed are low, moderate, and high. And then I can go back to my abstract info extractor to define a field name of list of related specialties. So it is a so this one is Pydantic object. So you should define it like you should select the object, and then from here you should select the object that you want to have. So the list of related objects is a list of these Pydantics. So it is a hierarchical, and the field description is the list of specialties and degree of relevance considering the abstract topic. Medical specialty. So yeah, list of related specialties, and that's it. So when you add this list of related specialties, which is an object, you will get the two other features inherited to this new final Pydantic object, and that's it. So I don't want to go like into other columns, but you can do this for and go with like all other columns that we can have here. Yeah, so you can also go with like doing the exactly the same thing with the experiment number 2. Let's have it as, so this is GPT-4o, sorry. I want to also know the same experiment with prompt engineered output. So yeah, with columns. So the column here should be abstract, sorry, prompt, temperature of 1. The name of the model should be GPT-4o mini, sorry, GPT-4o. Let's do prompt engineering for both of these things. So this is also prompt engineered, but this is GPT-4o mini. And the name of the model is this. This is the name of the model. Temperature is 1. Column is correct. Batch size is correct. Max token is, you can decrease the max token for sure, for the especially for this case, but I will not use that. But let me show you a cool thing that you can do inside your OpenAI platform nowadays. So inside your OpenAI platform, you can see when you are logged in, you can see the playground here, and you can actually go with some improving the prompt. So extract the information about this scientific abstract. Provide, this is super important. I have the code to add this sentence regardless of you inserting this sentence or not. But when you want to get a clean output, you should define, you should have a command like this: provide your output in a structured JSON. Extract the information about this scientific abstract. Show your ability, your knowledge of developing machine learning models in medicine, and your understanding of medical specialties. And then you can go with this generating. Sorry, where is that? You can get the improved system prompt. It's really cool. It is really complex. Extract the information, additional detail, identify key element has. So these are not, these are it. So in medicine, demonstrate your understanding of developing, present your findings. So this is, I will just use this one. Yeah, so this is my system prompt for both of these experiments. And I guess that's it. So I don't want to define the Pydantic object again. I will just change the code to use the previous one. So it's almost done. Yeah, it's done. So now you can press provide the code, and it will import all of the libraries, the codes that I created for you guys to do your experiments. It will get your API key and read it as the API key and check if it's working or not. It will define the experiment configs, which is a list of dictionaries. Each dictionary contains one experiment. This is experiment name, Excel path, prompt column, temperature, model. I see that I set the temperature here as 1.1, but anyway. The temperature, model name, max token, system prompt, batch size, and all other things that I defined. This is the base output folder. So this is the folder that we want to save our outputs. This is the base URL I defined here. This is your API key. And these are the classes. So we defined a class name, specialty relevance, with the specialty name and degree of relevance, which is inherited inside in here, which is like this is list of related specialties. This is a list of a specialty relevance. And we have the descriptions here. It's great. And this is where you will loop through all of these things to run multiple experiments using asynchronous ability. And that's it. So you just need to copy this one and print and go to the notebook and go to the create a new cell, print it out, and then press run. And oh, sorry, I wanted to provide this Pydantic object here. Where is that? So this is Pydantic models. Sorry, I forgot to add this one. So you should remember to select the root object, which is the main object. Our root object here is special abstract. So yeah, provide the raw code. So for each experiment, we can define the Pydantic object we want to use. I want to manually use this the second experiment name here and say that I want to use this Pydantic for the second experiment. And that's it. Now I want to run this and I'm a bit nervous. Let's see. Oh, I should I should select the Python environment. Let me show you. So when I run this, I should use the select the kernel. You can also select it here. So I want to create the venv. It already understands that I created a venv here. So yeah, I will go with this one. And then again, it's running smoothly so far. So why we have we have 2 bags, so there's something wrong in this. I guess that error is resolved now. Let's pray and run it again. If it resolves the error, yeah, you can't believe it, but if you set the temperature, okay, it's done. So there was an error with the how I manage the temperature. So now it's done, but previously if you set the temperature higher than 1, it would be it would cause errors due to my code for sure. So it's done. You can see that the first Excel file, the first experiment was 2 batches because we had less than 60 rows, and each request includes 30 requests. So it's done, and it took us 43 seconds for running 2 experiments for about 59 rows. So it's done. When it's done, you should go to the output folder. So this is the output folder. Let me show you. So this is the output folder that we defined. You can see that each experiment has its timestamp. So if you run this again, it would be saved inside another folder. And inside each folder, you would have your experiments inside one folder. And this is the experiment summary. So this is the experiment summary. So both of them was successful, and you can see that each one has 39 complete instances. So inside each folder, you can see the inputs. So these are our inputs to the model. If you want to know them, it's here. We have the model, temperature, max token, and prompt. And this is the output of the model in as Excel file, and also the in JSON format. So let me close these Excel files. So this is the output file, and as you can see here, you can see that this is the temperature model. How should I increase the the model, the max token, system prompt, clean response. This is the clean response we received. And this is the inference time, prompt token and completion token, like input token and output token. And this is the reason for the model to end the generation. If you see a stop, it means that all of the things are successful. If you see length, which it means that your max token is lower than what is required for the LLM to give you the answer. So it's super important to know this. And this is the raw response, and this is the structure output that you should see. So let's go to the JSON file because it is easier to see the output. So yeah, it's not easier. Yeah. So this is the output, but it is not clean. I just want to show it in a clean way. Let me open up text file. So yeah, let me copy and paste one output to show you the magic. So inside the structure output, I have the output here. So this is the output. It is a dictionary. We have the disease, and for the disease we have hepatocellular carcinoma. For the patient sample size, we have like the number 67. For the number of events, we have 197. And look at this one. This is the most amazing thing that you can do. So for the list of related specialties, we have a list. Let me separate it out. So this is the list, and for each list we have the specialty name and degree of relevance. So it's really cool that you can get the output like this. So as you can see, it is a list of dictionaries, and for each dictionary we have a specialty name, degree of relevance, and so on. And let's just look at this example, look at the abstract to see the correctness of our response. So this is the title. So deep learning based compressed sense improved diffusion weighted image quality and liver cancer detection, a prospective study. So it is about hepatocellular carcinoma. Hepatocellular carcinoma, what is the aim? To assess whether diffusion weighted imaging with compressed sense and deep learning can improve image quality and lesion detection. So it is related to radiologists for sure, also oncologists and gastroenterologists. It's really amazing. So what about number of events and number of patients? How many patients do we have? So it's 67 patients and 197 clinical relevant liver lesions. It's amazing. You can do many great stuff with these tools. So let's check out it was GPT. Oh, and as you can see, it is like the results of GPT-4o mini. So it's amazing. Let's do the same thing, but this time with Firework. So that's it. This is how you should run your experiments and get the output. And from this point on, you can just like modify the output and extract those information. But what about running open source models? So you can go with Firework. I really love it because you can do many great stuff. If you go to my models, you can get your API again with the same approach and steps. Let me first remove my API key. So we are safe now. Yeah, so you can get your API here, and then you can go to my models, and you can go with explore the model library, and it is OpenAI compatible, which means that you can do many great stuff with open source models. And you should filter out for serverless. You can also deploy your own model. You can upload your model and serve it, but it will work, but downloading the models and uploading the models and setting them up is a bit like tricky. So you can go with serverless. You can use all of these models without any challenge. So let me go with Llama. Oh, let's go with Llama 3.3. This is like just published. So this is the model name that we should have. So I would remove the experiment number 2, and for the experiment number 1, I want to use Firework. This is the API. There's no need to change it, but I should put my Firework API inside my environment, and this is okay. The experiment name is the same thing, but now we want to have Llama 3.7b7t, and Excel file path prompt temperature should be 1. The model name is like this: account slash firework slash models slash some model name, and all of these other things are the same. This is the same. Let's get this output. Oh, I should add my API. Just a second. Just remember that when you set your .m file, you should restart your kernel and run the code again. So otherwise, it wouldn't recognize your API. So this is the code. I should correct this part. So the model name is correct. All of the things seems to be correct. Let's wish that we wouldn't run into any problem. Yeah. Yeah, we should have 2 experiments. There is error in handler. So it is possible that sometimes invalid request error. Okay, got that. Got the issue. Let me fix it. So this issue is done also. So yeah, these were 2 really small issues. So it is good to know that OpenAI would support a new way for using Pydantic objects, which is really like the performance is significantly better than previous way of using JSON schemas. So I added this JSON schema for my own open source models, but I haven't added this to the code to this ezExperimenter, so it's done now. I defined the just JSON a new object, and this would just like resolve the open source models. So all of the models are JSON compatible, but some of them are structured output compatible, which means that they can inherently ingest the Pydantic. Anyway, so it's done. Let's look at the outputs. It's really cool to see what happened. Yeah. So as you can see, it is a new batch. And let's check out the output for the same row. This video turned out to be a really long one. Sorry for this issue. So yeah, it's really good. Now we can have high quality open source models. Cheers to, sorry, my computer is running something, so yeah, I should close everything. I'm currently running a fine-tuning task, so yeah, it's better now. So as you can see, let me copy and paste it for you. So, oh, sorry. Yeah, so this is the output for the Llama 3.3 hepatocellular carcinoma is good. Sample size is correct. Number of events is correct, and radiology high, oncology high, gastroenterology moderate. It's really good. As you can see, it's reached the performance of GPT-4o mini at least. So yeah, that's it for now. I hope that you can use it for your own use cases. Is there anything to add? Let me see. The last thing to add is on Runpod and HuggingFace and Ollama. So for the Runpod, you can go and create a serverless thing for you. You should just define your HuggingFace model and HuggingFace token to download that, and then you can use this server. Let me show you. So this is my. So yeah, you can go with selecting your GPU. You should have some level of like experience with LLMs to define these GPUs. And then you can also define up to 5 workers to send 5 requests in your batch size. For HuggingFace, you can get your model name here. This is the model name. and this is, you should get your API key, and you can see it is OpenAI compatible, which means this is the URL you should put into the to this server. So with Ollama, things are a bit different. So you first need to download Ollama. Let me show you. You should first download Ollama, and each time that you want to use it, you should start running Ollama. So it's here. Now we can access Ollama through this API. This is the API to access to Ollama. And to pull, so you should go with their documentation, but if you want to just see Ollama list, I guess it will list, no, sorry, let me go to their documentation. Ollama documentation. Yeah, Ollama model list, maybe. No. Where is this list? List local models. Oh, it's not Python version. Sorry, this is for not. Yeah. This is pip install Ollama. You can install it in Python also. You can use it in Python. Where is the list? Ollama list. Ollama list. Yeah. I don't know why. Oh, I had the typo. So yeah, these are the models that I have in my computer. So I am really in love with Qwen. So yeah. If you want to download anything, you can go with their, oh, they added Llama 3.3. So you can go with Llama 3.3. These are the parameters that you can have. Yeah, these are the versions. And for each versions, you can see there are different versions. So this is like Q4 quantize, Q8 quantize, and FP16. These are the precisions. I won't go deeper into explaining what are these quantized versions. So you can, but just know this is not Llama 3.2 full version. This is 4-bit quantized, which is 1/4 of the size of the original model, and also the quality would be lower for sure. So Ollama 3.3. So you just should sorry, first you should go with Ollama pool, this version, this model, which means that it will start downloading the model. So yeah, then you should, this is the model name that you should use. Let me use Qwen 2.53 billion. I don't know if it is like compatible with Pydantic, but let's see. Let's first make the data smaller. My PC is getting slower and slower. I'm recording a video and also running the code, running another code. So let's just have 2 rows. Really, it's not. So let's change the code. Here I want to use Ollama. There is no need to change the API, but there you should change the model name. So this is Qwen 2.5 3 billion parameter 4-bit quantized, and the model name is, where is the model name? Qwen 2.5. This is the model name. Actually, you can also change these things inside your notebook environment, so no big deal. But yeah, Let's see if it's gonna work or not. Sorry, I should change this. So everything is fine when, and the name of the model is Qwen 2.5. Yeah. Let's see, and let's also see the performance here. So I have a like good GPU. I have a like 16 gigabytes of dedicated GPU, so I can run many models on my PC. But let's see if it's gonna work or not. Oh, sorry. There is no need to use API. But where is that? There is no need to validate this. Basically, this line validate if the API key is valid inside the environment. So for this one, there is no need to get any environment variable. You just need to set it as something and then run it and see that if your GPU spikes, this means that the model is working. Yeah, it is working. I don't know if it is, it can provide the output in Pydantic. For validation error. So this is amazing because, oh, sorry. This is amazing. Do you know why? Because this error, it means that the Qwen is not able to provide the correct format for the JSON, which is super awesome because I have a code which will resolve this called exact, and I will create ezExperimenter. So this is a really good point to mention it. So yeah, let's see the output. If you interrupt the process, it will save the things that it done. So yeah, it is working. So it is working, but it is not able to parse the output, and it's awesome to see this one. Yeah, so this is the ID, this is the choice, this is the role, and this is the content. So this is the content we got. It's awful. We actually, this is the title, and is this the sound? No, this is the input, I guess. No, look at this one. So Qwen is not able to provide any meaningful output. This can also be due to the temperature. So the temperature for open source models should be lower than 1, like probably around 0.5 something. And also I don't want to get the output for all of these things, but let's just run it and see what happens. Yeah, I'm just making this video longer and longer. I promise that's okay. Also, you should set the, yeah, it is correct. So the code set the batch size to 1. When you are using local machine, you should just send the request one by one. The reason for the delay in starting the runs, the reason behind it is that it tries, I guess, to load the model. No, it's loaded. I don't know. Let's skip this one. And yeah, let's move on. So I will also create 2 other easy like the same easy UIs. The next one is ezExact, which is a really cool and error-free code for doing extraction. And then I would prefer ezFineTuner to fine-tune anything that you want using Firework or OpenAI. And also it works on with vision language models. I already tested it out, so it works. Let me know if there is anything wrong with this so I can improve it, and I wish you success in your projects. Yeah, bye bye for now.